Hey everyone! Do you know what happens to a component right before it leaves the screen forever? Today we're demystifying the architecture of the component lifecycle. Stick around to learn how to manage React phases at enterprise scale and prevent massive memory leaks. Let's jump in.
We'll kick things off with a macro view of software assembly. Jump straight into the three core runtime phases of a React component, which are mounting, updating, and unmounting, and then we'll zoom way back out to see how this universal concept applies across all engineering disciplines. Okay, before we even look at a single line of code or talk architecture, let's get our core concept straight. A component lifecycle isn't just some static text sitting in a file somewhere. It's an active, ongoing sequence of events that spans a component's entire existence. It's the full journey from the very moment it's summoned into existence through every single change it experiences while interacting with the user, right up to the exact second it is destroyed entirely.
Part 1. The macro context. What happens before a component even hits the screen? So think about it like this. Conceptually, a component is actually born in a design system long before it ever hits your codebase. It starts as a request, goes through triage, gets designed, and finally documented, kind of like launching a miniature product. And what's super cool is that this completely mirrors its technical birth, where it enters the document object model, or the DOM, through initialization methods in the actual code. It's really like a dual-track system running in perfect sync. You have parallel tracks happening at the exact same time. Developers are out there searching for existing components, selecting them and verifying them, right alongside the actual development of totally new systems. All of this heavy architectural planning and system integration has to happen before a component ever reaches the application runtime that we're about to dive into.
All right, transitioning to the real meat of our explainer. When a React component actually hits the screen and runs in your browser, it goes through three distinct biological life phases. Step 1 is mounting, that's its birth. Step 2 is updating, representing its growth and reaction to change. And step 3 is unmounting, its inevitable death.
Let's start right at the beginning. Phase 1, mounting, or, birth, entering the DOM. So during mounting, a class component relies on three massive steps. First up is the constructor. This is literally where you initialize the component's properties and set up its default starting state. Next is the render method. This is the one that actually defines what the initial user interface will look like and draws it right onto the screen for you. Finally, we have the specialized method called component-did-mount. It's a hook React gives us to execute custom code the very split second after the component is successfully born and placed on the screen. To make this super concrete, let's use an example. You would use this mount phase, specifically that component-did-mount method, to trigger an API request to get a list of products from your database. Why do it here? Well, if you try to fetch that data before the component is actually born, the system is going to throw an error at you because the destination doesn't even exist yet. It's also the perfect time to render a getting data loading spinner, so your user knows something is happening right as the component appears. Once it's born, the component moves right into phase 2, the updating phase, growth and reacting to change. Now, what's genuinely fascinating about this growth phase is a method called shouldComponentUpdate. This thing acts as a literal gatekeeper. It essentially asks a true or false question. Based on the new data we just got, does this component actually need to redraw itself? It gives you incredible control over performance. If it says true, the component calls the render method again to redraw the UI with the fresh state. And just like birth, growth has a hook too. Component-did-update, which lets you run custom logic like firing off analytics right after a successful visual update. Picture clicking a button on a website that shuffles a deck of pricing cards. That click is an event. It changes the internal state of the component. And that state change triggers the updating phase we just covered, telling React to do the absolute magic of seamlessly redrawing those specific cards in their new randomized positions, all without you having to reload the entire web page. But everything that lives has to end, right? What happens when the user navigates away or clicks a button that completely hides those pricing cards? This brings us to a massively critical question for your application's performance. Phase 3. Unmounting, leaving the DOM forever. The star player in this final phase is component will unmount. You really have to think of it as the component's final will and testament. Its entire job is to let developers clean up any running background tasks or side effects before the component vanishes into thin air. And the stakes here are high. If you fail to clean up these background tasks, they're going to keep running invisibly.
That leads to severe memory leaks and eventually a complete application crash. Here is a classic example. Let's say during the mounting phase, your component kicked off a background timer using setInterval that logs a message every single second. When that component gets removed from the screen, you absolutely have to use the component will unmount phase to call clear interval. If you skip this, that timer is going to run forever in the background like a ghost in the machine, just eating up your memory even though the visual component itself is completely gone. Okay, let's pull the lens back a bit. Section 5, Beyond React, the universal truth of life cycles. Because this isn't just a React thing. If we look at a different framework like Angular, you'll see they take a much more granular approach. Instead of our 3 relatively simple phases, Angular breaks it down into highly specific hooks. You have ng-on-init for birth, nd-check for watching changes, ng-after-view-init for when the template is ready, and ng-on-destroy for death. So the vocabulary changes, sure, but that underlying biological life cycle, it is completely identical. And we aren't even just talking about web browsers here. If you look at hardware engineering, say an embedded controller inside a commercial airplane, the component lifecycle expands from literally milliseconds on a web page to years or even decades. In hardware, the death phase only happens when the physical part faces actual hardware obsolescence. Dealing with that means doing wild things like mathematical models to estimate redesign costs versus executing a last-time buy to stockpile physical parts before they go out of production forever. Because ultimately, the golden rule here, whether you're building a React button or an airplane controller, is this. If you trigger a code at the wrong phase, you might get an error or an unexpected value, or maybe your application might even crash. Knowing when to trigger your logic during these life cycles is fundamentally just as crucial as knowing how to write the logic itself. Which leaves us with a pretty wild final thought to ponder today. As our design systems get smarter and frameworks evolve to make components even more autonomous and AI-driven, how is the very concept of a component's birth, its growth, and especially its death going to evolve next? Are components going to learn to self-terminate to optimize memory, or maybe just go into deep hibernation? It's a fascinating space to watch. Thanks for hanging out with me on this explainer. Keep building awesome stuff, and I will catch you next time.